Welcome to our first video lesson, video 1.1, Defining Matter. Today's lesson, you should be able to classify matter and its changes based on its properties. You should be able to define the states of matter and compare and contrast their properties. And you should be able to draw each of the states of matter using particle diagrams. Matter is anything that has mass and takes up space. The air around us is matter. The table and the chair that you're sitting at are matter. Everything in the universe is matter. Matter can be classified as 3 different phases. Actually, there are 4 phases, but we are going to stick with 3 major phases of matter. There are gases, and gases fill the volume of any container in which they are placed. The particles that make up gases are very, very spread apart. So we can actually take those particles and squeeze them together, and we say that gases are compressible. We can compress a gas so that the particles become closer together. The gas particles are very far apart from one another. That's because they have very weak attractive forces towards each other. Gas particles do not want to be near one another. Liquids have particles that are closer together than a gas. When we draw liquid particles, we're going to draw them so that they are slightly closer to each other and they are able to move past one another. They kind of slide past each other. When you put your hand through water, you can feel the molecules sliding past each other, and there's a fluid motion for the liquid particles. Liquids do not fill the volume of their container, but they do take the shape of their container. Solids are where the particles for the matter are packed as close as they can be. The solids have a definite shape and a definite volume. The chair that you're sitting on or the desk that you're standing near, all of those have a definite shape and they have a definite volume. A volume is the area in which, or the space that the matter is taking up. Particles that are packed very tightly together are not compressible anymore. They're as close to each other as they can get. Here we can see a picture of a solid, a liquid, and a gas. In the picture for the solid, you can see that the particles are packed as tightly as they can. When the New York State Regents refers to a solid, they always say that the particles are in a regular geometric pattern. Make sure that you write that in your notebook. Pause the video if you need more time. When you're drawing a solid, make sure that your particles are touching one another. Right here, there's very little space between the particles of the solid. Make sure that your particles are touching. When we talk about a liquid, there's more space between the particles. These particles are able to move or slide past one another. Liquids have no fixed shape. That means they will take the shape of any container that you place them in. But liquids always have a fixed volume. Gases, on the other hand, have very, very, very big spaces between their particles. That makes it very easy to move our hands through gases. They are not rigid, they have no fixed shape. If you take a gas, like helium gas, and place it in a balloon that is the shape of Mickey Mouse, the helium gas will be the shape of Mickey Mouse. We can also change the volume of a gas by changing the temperature of that said gas. So if we heat a gas up, the gas particles start to move more quickly. The more quickly they move, the more often they hit the inside of the container. If the container is not rigid, in other words, if the container is flexible like a latex balloon. Those gas particles will push out against the latex balloon like this, and it will cause the balloon to get bigger. So the volume of the gas will increase when we increase temperature. When we decrease the temperature of a gas, the opposite happens. The gas particles stop moving as quickly, so therefore they don't hit the walls of the container as frequently. Then the volume of the gas appears to get smaller. It is because of this we can say that the gases have no fixed volume. The other thing to keep in mind about gases is that the attractive forces between the particles of the gas, the force between the two gas particles is very, very weak, whereas the force of attraction between two solid particles is very strong. You should also note that when we change the volume of a gas, we are not changing the number of gas particles within the container. The number of gas particles is staying constant. We are just changing the volume. I hope this helped. Until next time.